There's a little company called Google. Ha ha ha, this is a joke because I said little. And they have to deal with quite a few people visiting their web page every day. How on earth does that work? I mean, imagine 1 billion people Googling for things at the same time. What kind of friggin' fast machine could handle that? No machine could handle that. There's no possible way. So how on earth does Google work? Given the fact that computers have hit their speed limit, they can't buy faster iron. They have to use lots of iron. So what does Google do? Yeah, there's not just one Google. When you go to google.com, it picks one of their machines and throws you to it, and you're talking to that machine. Well, so here's the front end, which we'll call Google. And here are all the back-end machines. And as soon as you visit them, it just throws you to one of them at random, right? Well, when you visit this machine, it turns out that behind that, there are thousands upon thousands of computers running in these massive data centers who all exist for, there, that looks like a lot of computers. All of them exist for one purpose, and that's to compare your query against something. So let's suppose that this computer happens to be the computer that is really good at understanding whether or not somebody is interested in cat videos. And so it's going to take as input, well, the computer that you get to talk to is going to farm off your query to a whole slew of machines. And let's suppose your query was bash cat myfile.txt, which, by the way, is a legitimate bash command. Cat prints stuff in bash, and it has nothing to do with kitties. Okay, it's an abbreviation for concatenate, and it concatenates your file to standard out, which is usually connected to the terminal, which is why it prints to the terminal. Now, if you were Googling a query like this, you're obviously interested in Linux, or something like that, or bash. So you type in the query, it gets sent to Google, it farms it out to all these machines, and this one machine that is good at recognizing cats reads this and says, hey, that has to do with cats, but those don't. And so it kind of returns a meh response. Whereas if you typed in fuzzy cat, big eyes, ears, or something, then it would definitely return a, this is totally cat. So all these different machines are producing results. Then what do? Well, we've got to reduce this. Do you see how we just did a map? We kind of mapped that query onto every single one of the machines. Well, then at some point we've got to reduce from all those machines down to one machine. And I guess we could just reduce all the way back to here again. It probably reduces to some other machine and then funnels it over, or something like that. But the great thing about this is even though you've typed in a single query, probably 50 hours of computation have been performed on that query in order to find really, really good results for you. But it's all happened in parallel on thousands of machines. And so all of the code that Google engineers write are going to be on these machines, and they're going to be written in these higher order functions that just take what you got, they're going to return a query and spit it back out. In fact, I don't know if it's written in a higher order function, but the thing as a whole is kind of higher order. And so your queries are in pieces all over the place, but then they come back together, and it makes it amazingly scalable. You can see why, right? Because Google's traffic meter goes into the red zone, and somebody says, oh, we need another machine. What do? They push a button, and 50 more machines come online to help with cat videos. And then the Olympics happen, and suddenly 1,000 machines are dedicated to Olympics queries. And they can handle it because there are so many machines back there ready to process pieces of the queries. And as far as the front-end machine knows, all they did was take this query and then map it through this massive array of candidates, things that you could have meant. And so you farm it out, you gather, you reduce, and return it, and it makes a very powerful, scalable thing. Okay, so if I were to ask you why are higher order functions a good thing, the answer is probably scalability. They allow you to operate in ways. You could rewrite the guts of your higher order function to allow your function to be applied to the collection however you choose. And thus you could scale to multiple machines, multiple threads, multiple whatevers you wanted. And there you go. I've kind of tried to sell functional programming to you. The nasty thing about functional programming is no member variables. You don't get to think about objects anymore. Everything is a function of a function of a function of a function. And you start doing all kinds of recursion, and if you want to get deep into it, we could learn about tail calls and closures. And I think I'll teach you about closures, and then we'll call that it for functional programming in this class.
Okay, I have a question.
Yeah.
About recursion.
Yes.
It's like recursion is not allowed to be working with the company.
The question is, are there companies that disallow recursion?
Yeah.
I am not aware of any. Recursion is kind of a powerful programming tool, so I don't know why recursion would be disallowed.
Sometimes it takes like stuff from the computer or something, or no?
Well,
What does that mean?
I don't know. Remember an assignment, remember the Mario AI one? We used recursion there, and that did some amazing things that you guys would not have been able to do without recursion, am I right? I mean, the idea of viewing the next phase of the world and then from that forking into the next phase of the world. It turns out anything that can be written recursively can also be written with loops. You just need to make a stack data structure and then process that stack, and it'll do the same thing as recursion. But recursion is a very powerful programming tool. I can't imagine any company saying never use recursion. That's kind of like taking your programmers and breaking their knees and then making them run, right? Okay, it's not that important. It's more like breaking their fingers and then making them run, but yeah, okay, bad example. Okay, there exist higher order functions. It's a good thing to learn about them. If you end up working at a company that does web stuff and you need to be highly scalable, or if you work at a company that does, I don't know what. Basically, people that really geek out about efficiency and high-end computer programming usually know about functional programming. If you tell people you passed a programming paradigms course and you didn't study functional programming, they'll say, whoa, you were totally ripped off. You got to study that. Truth is, I didn't cover it in great depth because I thought objects were really important for you to know well. And I think most paradigms classes rip the students off by not spending enough time on the things that they actually use in the real world. So, I don't know. There's an argument that functional programming is coming and is going to be increasingly important because Moore's law is dead, etc. But then there's also the argument of nobody uses it yet. It's still an academic curiosity, so I don't know.